In this lesson, we're going to talk about converting non-SAS data to SAS data. So far, what we've talked about is how to bring together and manipulate data sets that are already SAS data sets, or they have a file extension .sas7bdat. So we've been really talking about starting at this point and then moving forward. But quite often you end up getting data that's either in an Excel file or maybe a raw text file, an Access file, could be Stata, SPSS, etc., etc. And before we can analyze those data in SAS, generally speaking, there are some exceptions, but if you want to get the data into SAS and analyze it, you need to go through a couple of steps to make those conversions. So we're going to go through and talk about a couple of different examples. One example will be getting Excel data into SAS data. Another will be how to get some raw text files into SAS data. And then I'll also talk very briefly about how to get export files converted into SAS data sets. For this, we'll be using a couple of new data sets that have not been used previously throughout the lectures, and they're listed here. And the overall objectives are listed here also. So again, we're going to talk about using the SAS file-driven menus to import data from Excel, and that will be sort of a generic skeleton that can be used if you want to import many different data types into SAS. And we'll use just the Excel example in this particular lesson. I'll also show you how to create some import statements so that you could actually have the code in a SAS editor file to very rapidly import Excel files into SAS if you chose to do that, as opposed to going through the file-driven menu and some of those steps because they can be a bit cumbersome. We'll talk about how to use a data step to read in raw SAS data from external data files. I'm going to talk about INFORMATS, which are important for the content in this lesson, but INFORMATS are also valuable to know more generally in SAS, so that's an important concept to be aware of. And then in the end, I will talk about importing export files or files with a file extension of .xpt into a SAS format. And then finally, I'll show you very quickly how to use some and modify some SAS system options. So importing data from Excel. SAS does have the capability to walk you through data import using file-driven menus. And it allows you to import Excel type files or many other data types as well, such as Stata, SPSS, text files, and several others. So I'm going to go through an example where we'll import a file that is currently saved as an Excel file. The name of it is demographics, and this file is available to you on the course website. So we'll go over into SAS. And to do this, you'll simply start by going to the File menu. And then you want to select Import Data. So File, Import Data. And you'll get an initial screen that asks you what type of data you wish to import. And the default is Excel, so we don't have to change anything here. However, at this point, if you had a Stata file or some other file type that you wanted to import, this is where you would need to make a change. So you could click this drop-down menu, and you see a number of different file types that could be selected. So find the file type that fits your data and select it. But again, in this example, we're going to go with Excel, so we don't have to change a thing, and we can simply click on Next. And now we need to tell SAS where the file is that we want to import. So you would click on Browse, and then browse to the location on your computer where you've saved that file. So I'm browsing to a location on my computer where I've saved the demographics file, which is an Excel file. So I'll simply highlight it and click Open. and then we can click on OK. Now with Excel, oftentimes you have multiple worksheets and you need to specify which worksheet you want to import, and that can be done using the drop-down menu. In this example, there's only one worksheet, so SAS selects it by default and I don't need to change anything there. But if you had multiple worksheets with different data sets or data tables within one Excel file and you only wanted to import one of them, then you have to specify here which worksheet to import. And by default, SAS will only import one worksheet at a time, so you should specify the worksheet you would like imported at this step of the import. And then you click on Next. And now we need to give the name of the new SAS dataset. By default, SAS is going to put it into the work data library. If you have defined another SAS data library within this SAS working session, you could use this drop-down menu and select that data library. For example, had we run a libname statement and created the epic data library, we would find it here, and we could select that if we wanted. But since we haven't run the libname statement yet, epic does not appear, and I'm just going to allow this to import into the work data library, which means it will be a temporary SAS data set. And then I have to give it an actual name, and I'll just name it demographics. So this is equivalent to naming our SAS dataset work.demographics, if you're thinking about this from the perspective of a data step. Now we'll select Next. And then finally you have an option to create an editor file that will hold the actual import code that SAS uses to import the data. And this can often be helpful if you create the editor file, because then next time you get an updated version of this data set from the Data Coordinating Center, for example, you don't need to go through this slow, cumbersome set of imports or of import options using the file-driven menu. But instead you can just open up an editor file with the import code and highlight and submit it. So I'll click on Browse, and all we're doing here is we're browsing to a place on our computer where we want to save the import code, and then we'll give it a name. And I'm going to save this on my desktop, and I'll just name it Import Demo. You can give it any name you like. And then I'll click on Save, and finally you simply click Finish. And if you go to the log file, it should tell you work.demographics was successfully created. Okay. So now, if you were to go to the libraries window over here and then into the work data library, you see we have a SAS dataset named demographics. So it's successfully imported. And if we wanted to create a new editor file, we could, for example, run a proc print data equal work.demographics, run. And there we have a proc print. So this is a real live SAS dataset saved in the temporary data library, or in other words, in the work data library. And if you want to open the editor file that we used to create this, you would simply click Open, and you would open, follow the steps necessary to open any other editor file. So here I'll scroll to the place where I saved it. It was on the desktop, and I named it Import Demo. So there it is, and I can open it up. And this is the actual code that SAS uses to import. So as you can see, if you wanted, you could just learn how to use proc import directly, but the file-driven menus are fairly easy and not too time-consuming, and it allows you to create an example of import code that would be valuable to you or useful to import a particular data set, and then you can simply save that and reuse it over and over again if you're getting newer versions of that data set. So you could choose to create this editor file and save it if you like, but if you don't mind going through the file-driven menu steps, you could simply resort to that each time you needed to import some sort of non-SAS data set into a SAS data set. And it's as simple as that. With that, you've imported an Excel file to SAS, and you can move forward then further operationalizing and modifying that data set in the ways that suit the analysis you're planning. In the slides, I've simply included step-by-step instructions so that you can follow through in the slides if that's valuable to you without having to rewatch the video. Okay, so now I want to move on and talk about reading in non-SAS data to a SAS data set using a data step. Now, so far in this course, we have talked about two different statements within the body of a data step that can be used to somehow join together or merge or stack or modify existing SAS data sets. That's been the merge statement and the set statement. So now we're going to move on and we're going to talk about using an in-file statement. The in-file statement is used generally speaking, when you have data that exists in a non-SAS format. So in these examples, we have data that are saved in text files, .txt files, for this particular set of examples, and we want to import them or read them in so that they exist within the body of a SAS data set. And in order to do that, we're still going to use a data step, but instead of using a merge or a set statement, after our data statement, we're instead going to use an in-file statement. This is just an example of what some raw data might look like. They're generally speaking just a collection of numbers and letters that don't appear to make any sense in the body of a text file, but there's some sort of code book that should come with it, and it will tell you exactly what each number in each column position of the file represents. So you can envision these data as some sort of data arising from a questionnaire. There may be a lot of zeros, ones, and twos that correspond to yeses and nos or refused responses on a questionnaire, and so on and so forth. There could be weights and ages and blood pressures and all kinds of different variables mixed in here, and we want to somehow pull that into a SAS data set in some sort of meaningful way. This is simply another example. This example actually comes from NHANES dietary data. So when you're thinking about reading in or importing raw data into a SAS data set, there are a few things that you should be considering. First of all, the data location. When you're doing this in SAS, the data can be located either in-stream or they can be external. In-stream simply refers to data that you would actually enter in the editor file itself. It's good for very small and simple data sets, and throughout this course you'll see some examples where I read data in from an in-stream location for teaching purposes, but generally speaking, epidemiological data sets don't tend to be small. They tend to be fairly large and complicated, and therefore in-stream locations are not terribly useful. So I'm not going to go over in-stream imports. Instead, I'm going to talk about getting data from an external location. And external simply means that the data are stored somewhere on your computer, and you're going to need to tell SAS the folder that the data set is located in and the name of the actual file. In addition to the data location, there are various input styles that can be used, and I'll talk very briefly about list and column input styles and also formats that go with those. So I'll show sort of some quick and condensed examples that can be used to help you think about reading data in and applying it to your own data sets. And there's much more information on these various options and input styles in the textbook. I recommend that you read that chapter carefully, because reading in data from an external source is not an entirely intuitive concept, and some of the jargon and steps that will follow here really need to be practiced with some hands-on application in SAS and then going back and probably rewatching this a few times and maybe going through the textbook and getting some pointers there as well. So there are also a few other factors to consider as you're doing this. And one important thing is to be thinking about the input record data arrangement. So generally speaking, the data will be arranged so that either each variable is aligned in columns, or each variable, the data held by each variable, will be separated by blanks or some other character, like a comma. And I'll show some more intuitive examples as we move forward. And then you also want to consider whether or not the actual values in your variable might be separated by embedded blanks, because that will impact the type of input style that you want to use. You might also want to consider whether or not you have numeric data or even non-numeric data that has various symbols, so percent signs and dollar signs and commas, things of that nature, often need to be handled in a special way by SAS if you're reading in from an external file. Dates need to be handled in a very specific way, as do times, and we'll talk about that in more detail. And if you have data for which a single observation, or for example a single patient or participant in your study, is entered on multiple rows in the input file, you will have to provide some specific information to SAS about that. So I want to start with an example of list input, and we'll just get right into the code and show it to you and talk about what's happening exactly. Here we have a data step, and as we've seen before, we start a data step with a data statement, and we name the location and actual name of our new SAS data set. So here I'm telling SAS I want to create a new data set in the temporary data library work, and I want to name it Club 1. Now the next statement is an in-file statement, and this is new. Previously we've been using either merge or set statements, and in this example we're using an in-file statement. All the in-file statement does is it tells SAS where on your computer the external data set is located. And be aware that in addition to specifying the file path specific to your computer, you also need to specify the actual name of the data file. So in this example, you would fill in a file path, and then you would point it to the club1.txt text file that was provided to you via the course website. In addition, we have a misover statement. And what the misover statement does is it essentially tells SAS how to handle missing variables. And I'll show an example of that as we go on. But very briefly, without a misover statement, if SAS comes to a place where it's expecting data and there are no data there, it will just keep reading, and it will read until it finds some data, and the first set of data it comes to, it will read into that variable. So in epidemiological data, oftentimes we have missing data, and if a participant has missing data for a certain variable, what SAS would do without the misover statement is say, okay, I'm expecting a value for, let's say, blood pressure, but I don't see any actual values here in the raw file, so I'm just going to keep reading until I come upon a number and then read it into the blood pressure variable. Well, it may be that the next number it comes upon is the age of the participant, because that would be the next variable in the data set, for example. So then what's happening is SAS is reading in the age for the blood pressure, and it will continue to read in data variables in an inappropriate fashion for the rest of that particular observation. So misover statements tell SAS how to handle missing data, and I recommend always using one. And here we have next an input statement, and the input statement simply tells SAS the variables that you want to input. So in this input statement, you need to specify the names of the variables, and these are user-defined names, so you can define them however you like. you'll need to have some information from a code book that the data manager would provide to you that gives you information about what the variables actually represent. And in this particular data set, if you actually open up Club 1 and look at it, you'll see that how the data are structured, and I can just tell you that the first piece of information in that data set is the ID number, and I'm just going to name it ID number. So this is the unique identifier for participants. Then next is a name for a participant, then a team name, then their start weights and their end weights. So I'm just defining those variable names right there. And SAS now knows that it's going to read through and it's going to input 1, 2, 3, 4, 5 different variables. And because by default SAS will read in data assuming that it's space delimited, it knows that each variable is, or you're changing from one variable to the next in the original input file whenever it sees a space. So if you open up that club1.txt text file, you'll see that there are spaces in between each new variable on each row. So let's just go into SAS and give that a try. I don't need these anymore, so I can close them down. And here's what the input code would look like in SAS. So again, start with the data statement and name your new SAS data set. Then you need an in-file statement that tells SAS the file path, the full file path to the data set, as well as the actual name of the raw data file. And then I always recommend using a misover statement. This is, or excuse me, a misover option to the in-file statement. So SAS knows how to handle missing data if there are any missing data. And then finally, an input statement where you name your new variables. And I should also say that these dollar signs simply indicate that the variable coming before the dollar sign should be read in as a character variable. So usually you would use an in format like this to specify some sort of character variable. And in this example, the non-numeric data we have are for the variable name and the variable team. So we have a dollar sign coming after each of those variables to tell SAS that this is a word, not a number, effectively. We'll talk more about INFORMATS soon. And now you can simply highlight that and submit it. Check the log file. Everything appears to be normal there. And then this is what your new SAS dataset looks like. So we have an ID number, a name, a team, start weights, and end weights. And you see there are a few people with missing data for the end weight. And if you were to actually go and find the club1.txt file and open it up, you would see this same structure with the same values. And then that's it. You now read in a pretty simple data set that is space delimited, or in other words, the values for the data are separated on each row by a space. Now, oftentimes you may get a raw data file where the data are separated by things other than spaces. A common delimiter is either a tab or a comma, and in this example, I'm showing you how you would input comma delimited data. And the only addition that you would need is this DLM equals option. So this is specifying the delimiter. And then in quotation marks, you would specify the actual character that will delimit the files. So in this example, we have a comma delimited file, so we tell SAS that a comma is going to separate the files. And depending on what the delimiter for your file is, you would simply look that up in the SAS user's guide to figure out what the codes are for various delimiters, and then you can specify those in quotation marks, and SAS will know how to handle that. So now I want to move on and talk about another type of import style, that can be very helpful and is really much more common in epidemiological data because it gives you more control over how you read data into the SAS dataset. And we'll talk specifically here about using column formatted input with column pointers and INFORMATS. And all of these sort of obscure terms will be defined here shortly. So first, just a quick snapshot of what column formatted data would look like. This could be viewed as a raw data file, and if you open up one of the club files that we're going to be importing here shortly, you would see that I have some files formatted in this way, and the key point is that the values for each variable always start in the same column. So the first 4 columns of each row holds information about the unique identifier. Okay, so this always starts in row 1 and goes as long as row 4, and then there's a space. And then we have the first name of the participants, which always starts in row 6, and then it goes all the way out as far as row 11. And then there's a space, and then in row 13 we start with the team name, and so on and so forth. And you can see that each new variable is always starting in the same row. Some variables have consistent lengths, and some variables have variable lengths, such as the team and the name, which people have different lengths of names, and the colors have that we're using for team also have different lengths. So just keep that in mind, and then what the data structure looks like. And you'll see from time to time in the log files this column ruler, and all this is a counter. It just tells you what row, what column of any given row that you might be in. So this is simply 1, 2, 3, counting up to 10, 20, and 30. And it helps identify what particular row a variable might start in. But information of this nature will almost always be provided to you by a data manager when you get the data, so that you can set up the code for import appropriately. And here's an example of what the import code would look like if you're reading in data that are column formatted. And as long as you have a little information about what columns the data start with, what columns the data start in, and then how long each variable is, you can very quickly read that data in. So again, we start with the data statement. This time I'm going to name the dataset work.club2. Again, we have an in-file statement. And the in-file statement, again, you specify the file path where the external data are located, and then the name of that file. Again, the miss overstatement is highly recommended to avoid mishandling missing data. And then you move on to an input statement, where again you specify to SAS the names of the variables that you're going to read in. So again, I have ID number, name, team, start weight, and end weight. These are variable names that I've chosen. They're user defined, so if you wanted, you could just name this ID instead of ID number. That's up to you. Now, in addition, you can see in the input statement that we have these @ symbols followed by a number. The @ symbols are column pointers, and they simply tell SAS what column of the row does the variable that you're specifying start in. So we're telling SAS here that the variable ID number starts at column 1, and then with the in format at the end. So in this example, 4 dot is the in format for the ID number variable. We're telling SAS, is it a number or a word, and how long is it? And we're going to say that the ID number is up to 4 columns wide. And as you saw in the example in the previous slide, all of the ID numbers are exactly 4 columns wide. Sometimes you may have ID numbers that range from 1 column wide to 4 or 5 or 6 columns wide, depending on how many participants you have. And the key is that your in format should be as long as the longest ID number, or as long as the longest variable that you're importing. And then we just move on and we specify this information for each variable in the data set. The variable that we're calling name starts at column 6. It is a word or a string of characters. So we use the $sign to specify that, followed by the length of the variable. This can be up to 6 columns wide. So we specify 6, and then the INFORMATS always end with the dot. The team variable starts at column 13. It's again a character variable, and it's up to 6 columns wide. The start weight variable starts at column 20. It's up to 3 columns wide, and the end weight variable starts at column 24, and it's up to 3 columns wide as well. Then we have a semicolon and a run. And if we go over to SAS, into the editor file, we can highlight that, submit it, take a look at the log file. This is the message we're getting, so everything seems to have worked correctly. And then if you want to print the data set or run a proc contents, you could do that. So I'll run a proc print and a proc contents so we can view the data and get a little bit of additional information. So again, the data look just as they did when we used the list input. The difference is that if you look back to the 2 sets of code with the list input, we read in a different SAS data set that was not formatted in a column formatted way. It was simply formatted such that variables were separated by spaces. And in the column formatted data, all variables started in the same column on each row. And here's the proc contents. So we have 6 observations and 5 variables. And this gives us a little bit of information about the types of variables we have. So the thing I want to point out here in the proc contents is that both the name and the team variables are specified as character variables. And that is because we told SAS that they were character variables by using an in format that started with a $sign. Now, a little bit more about the miss overstatement to give you a bit more sense for what happens if you don't use it and you have missing data. So on the top of the slide here, this is essentially a proc print of the correct data set. You see that there were 6 different observations and 5 variables. And importantly, Amelia, Ravi, and Jim are all missing their end weights. And this is the way the data should look. They really are missing the end weights. They didn't come for their follow-up exam. So that is correct. Without a miss overstatement in SAS, this is actually the lower half of the slide is what the data would look like when you ran a proc print after importing. And what happens is that when SAS comes to a missing value, it just keeps reading until it gets the first piece of information it can find, and it reads it in for that missing value. So let's take a look at it here. The first observation in the data set, in the raw data set we were reading in, is David. And everything reads in correctly here. You can see David's team read, his ID number is correct, the start weight and the end weight are identical to what the correct information should be as specified up above. Now the next observation in the data set is Amelia. And for Amelia, we see that there's the correct ID number, the correct name, the correct team, the start weight is 145, which is correct, but the end weight is supposed to be missing, and in fact what we see is it has a value of 121. Now what happened was in the raw data file when SAS came to the missing value for end weight, it wasn't told that it's okay for values to be missing with the miss overstatement, so it kept reading looking for some sort of data. And since there are no more data on that line, it went to the next line, and the first thing it saw was the ID number for Alan, which is 1219. So SAS read in 121 because the in format for end weight specifies that the variable should be 3 columns wide. So it read in the first 3 columns of data it could find, which happened to be 121, corresponding to the first 3 numbers in the ID number for Alan. So completely unrelated information. We wanted start weight for Amelia, which was actually missing, and instead what we got was the first 3 digits of the ID number for Alan in the new data set. And the really big problem here is that this actually looks like a reasonable end weight. As a result, it would be hard to catch if you actually imported the data incorrectly and you were doing some QA and looking at distributions. Okay, so that's why using a misoverstatement is pretty important. And then after it got the information it needed to complete reading in the variables specified for Amelia, then it just stopped, which means it stopped reading any further on the line where where Alan's data were entered, and it went to the next line and it started again with Ravi, and then Ravi had a similar problem where it should have had a missing end weight, but instead his end weight ends up being 107, which are the first 3 digits for the ID number of Ashley. And so on and so forth. This problem would propagate throughout the entire reading in of the external data set into the new SAS data set. So again, if this isn't entirely clear at first and you need to rethink it and watch this a few times, just know that the key point about a misoverstatement is that it helps SAS know how to deal with missing values by simply telling SAS, if you find a missing value, miss over it and keep reading, go on to the next variable. Another option that can be useful to the in-file statement is the LRECL or the LRECL option. And all this does is it tells SAS how long the longest row of data would be. How many columns wide is the widest row of data in your data set. And it's necessary because in many operating environments, SAS is going to assume that each row of data can only be 256 columns wide. And if you have a really large data set where maybe many of the rows are 2,000 columns wide because you've asked about many variables and each variable requires several columns to hold the data, SAS will simply stop reading in at the 256 column, and as a result, your new SAS data set that you create will be truncated. So many of the variables you're expecting to be in that data set simply won't be there. And it's very easy to control if you simply add this option to the in-file statement as demonstrated here below. You simply type in LRECL equals and specify the length of the widest observation that you're going to be reading in. And again, this is something that generally would be specified to you by a data manager who's giving you the data. Now let's move on and talk a little bit about INFORMATS and data types. So an INFORMAT is simply an instruction that SAS uses to read data values into a variable. And there are 3 general types. First, there's a numeric. This simply refers to numbers, telling SAS that the variable that we're creating here is going to hold numbers. And it allows you to read in numbers that have commas or dollar signs or percent signs, decimal places, etc. And the general format or the general structure, I should say, of these INFORMATS is w.d all by itself. So we've seen some INFORMATS already where we have a number and a dot. So far we haven't specified the decimal. The W stands for width and the D stands for decimal. So we've seen a few examples of this. Or there are also this is a generic INFORMAT, And what SAS does is it creates many, many different kinds of informats that you can use in different settings. We'll see a few in a moment. And those specific informats usually have some sort of name here that would replace the word informat, and they end with a w.d. There are date informats, and date informats simply will allow you to handle raw data that is a date, and you want SAS to know that it's a date. And effectively what happens is SAS converts dates into numbers if it knows that it's supposed to do that. And by converting the dates into numbers, then you can perform calculations, so you can get follow-up times and ages and things of that nature based on information that is originally provided to you in the form of a date. Again, we'll see examples of this. And then finally, there are character variables. And character variables, the most important thing to remember is that they generally will always start with the $sign. So a very simple informat would be a $W saying this is a character variable, and then telling SAS the width of that variable. And there are more complex informats where you can give a specific name of a pre-existing informat followed by the width. So here are a few examples. Here is a basic numeric informat, w.d. If we were reading in raw data that took on the form 1, 2, 3, 4, in our input statement, we would specify input, we'd give the variable name, and we would end it with 5 dot, and this is what the resulting value would look like in the new SAS data set. So what happens here is because we gave within the input statement, we used an informat that told SAS the variable is up to 5 columns wide, and the decimal place should be moved in 1 space. What it did was it read in the raw 1, 2, 3, 4, and it gave us a value of 123.4. And you can see 2 more examples here, what the original data looked like and what the new data would look like in the input SAS data set. So in these 2 examples, the decimal was already present in the raw data set, and that was fine. SAS was able to read it in, and it just kept the decimal in that place by using the 5.1 informat. Next is an example of a comma informat. So the syntax for this informat is simply the word comma and then with dot decimal. And this type of informat is again an informat that SAS programmers have already created. It's a part of the software. It comes with certain rules and instructions that SAS understands. And if you apply this informat to a variable, it will follow the rules and instructions that come with it. So for example, the comma informat is commonly used when you're reading in raw data that contains commas. So you might have some raw data in this format, some incomes or something like that, or something with a specification of currency, and then you have commas embedded in that. And as a part of the comma informat, SAS knows that this is a number, and it can strip off the $signs and the commas and just leave you with the actual number if you'd like SAS to read it in that way. So again, here's what the data might look like in the raw data set. Then in an input statement, you would specify your variable name, whatever you wanted to name the variable, and follow it with the informat comma 10 dot in this example, and this is what the resulting data would look like in SAS. And it's a similar principle for the percent %w dot informat. And there are many, many different kinds of informats, dozens and dozens of informats that you can look up in the SAS user guide. Here I just provided a few to give you a sense of what they look like. Now let's go into SAS and just go through a quick example where we actually take a variable that we want to be a number and we tell SAS to read it in as a character. And specifically, we're going to tell SAS to read start weight in as a character. So this is sort of a generic in format where we have the width is 3, there are no decimal places, and we're telling SAS with the $sign that the variable start weight, or in other words, the data you read into this new variable start weight, which starts at column 20 and will be up to 3 columns long, we want you to view this SAS as a word effectively. So here's the code for that. I'll highlight it, run a proc prints and just a proc contents. So first of all, when you run the proc print, you see that start weight looks like numbers. So SAS is going to read it in as it appears in the raw data file, and to our eyes, this still looks like a number. But if you go to proc contents and you look at the variable start weight, you'll see that it's now specified by SAS as being a character variable instead of a number. And the reason that's a problem is because SAS doesn't do calculations on letters or words. It only does calculations on numbers. So in this new data set we just created, if we tried to run a proc means on the variable start weight, we would go to the log and we'd see an error which specifies that the variable start weight in the variable list that we gave does not match the type prescribed for this list, which is just SAS's very obscure way of saying you're trying to calculate the mean of a word, and I can't do that. Now to demonstrate an in format that would place a decimal, again I'm going to modify start weight in this data step. And instead of 3 dot, I'm going to use the in format 3.1. So it will place a decimal point in the values for start weight that I read into the new SAS data set. So now instead of 189 for David's start weight, we have 18.9, and so on and so forth. To apply these correctly, you obviously need to know what the intended data that you're reading in should really be. And in some really large data sets, particularly some old data sets that the CDC put together many years ago, oftentimes they would maybe measure heights in centimeters, but they would take the decimal places out if there were decimal places that should be there. And they did it primarily because it saved a lot of space. If you have many variables and tens of thousands of observations, and you get rid of, therefore, tens or even hundreds of thousands of decimal places within a data file, it actually saves quite a bit of space and takes up less memory. And this was at a time when memory was very valuable. So in any case, you may come across data sets where the decimals have been removed, and they'll tell you that in the code book, and then you have to put them back in with an in format. Now let's talk a little bit about dates. Now technically dates could be viewed as either a numeric variable or a character variable depending on the in format you use. But when SAS is instructed by you using an in format that a variable is actually a date, it's viewed by SAS as a number. And that's important because in epidemiological analyses, usually we get dates in the form of birth dates or baseline examination dates, follow-up dates, death dates, date of a heart attack, etc. And we need to be able to convert those dates into numbers so that we can perform the appropriate calculations and analyses that are based on follow-up times until death or event, etc. And to calculate that number, what SAS does is it converts the date into the number of days since January 1st, 1960. It needs to pick some reference that would be constant for all situations or all observations in the data set. And SAS by convention just uses January 1st, 1960. So that means if you have a date, if you read in a date of January 31st, 1960, and you tell SAS that it's a date by using the correct in format, when it reads that into your new SAS data set, the value of that variable now will be 30 in the new SAS data set. And that's because the difference between January 31st and January 1st, 1960 is 30 days. SAS has several different date informats that are useful. And there are many more than what I'm specifying here, but these are three that are pretty helpful and commonly used and can handle a lot of common date formats. So as an example, imagine you have an input data in which all of your dates are entered as 2 digits of the corresponding to day, followed by 3 digits, which are a month abbreviation, followed by 4 digits corresponding to year. You could use a date W format to tell SAS how to read that in and tell SAS that it's a date. And in this example, since we have 1, 2, 3, 4, 5, 6, 7, 8, 9 columns of data, we'd want to use a date 9 dot telling SAS this is a date and it's up to 9 columns wide. Again, you would have your input statement where you're specifying all of your variable names and date, or excuse me, all of your variable names and INFORMATs. And for the actual date variables, you would give your variable name an actual name and then specify the date INFORMAT. And in this example, it would be date 9 dot. And if SAS actually read in a date of January 1st, 1961, it would put a value into your SAS data set of 366 because there are 366 days between the 1st of January 1961 and the 1st of January 1960. And you can see this applied in different examples here on this particular slide. So let's add a date INFORMAT and an actual date variable by reading in yet another raw data file. This data file is going to be club3date.txt, which was provided to you on the course website. So nothing overall is really changing in this data step, except we're reading in a different external file, and that external file has a date variable starting in in column 28. I'm going to name that variable date, and I want to apply the date 7 dot INFORMAT. So here it is in SAS. I'll highlight that as well as a proc print and a proc contents. And now you can see that the date variable has actual numbers. If you open that raw file, you'll see that it didn't have numbers originally. It had something we would associate with dates more commonly, a 01 Jan and then a year, for example. And in situations where the date was missing, you still have a missing value. And if you look at the proc contents, you can see for the date variable, SAS is viewing this as a number. Now in this next example, I'm still going to read in the date variable into one variable named date using the date 7 INFORMAT. But I'm also going to read that same information into a second variable that I'll name date 2. And I'm going to specify that this be a character variable. So what I'm telling SAS here with the $7 dot is whatever you see starting in column 28 that you're reading into the variable date 2, it can be up to 7 columns long, and you should view it as a character or as a word. So now SAS won't have instructions to look at that information as a date, and as a result, the variable will have different internal properties and it will appear differently when we run a proc print. So now date 2, because we specified that the information being read in was simply to be read in verbatim as a word, SAS reads in exactly what it sees starting at column 28 and going 7 columns wide. But still, for the original date variable that we read in the previous example, because we use the date 7 INFORMAT, SAS reads it in and it's able to convert it to a number. And again, that number represents the time between January 1st, 1960 and whatever date is specified. Just a quick note about the overall formatting of your syntax. You don't have to have each variable and column pointer and INFORMAT on a different row. It's a little bit more readable that way, but if you have really large numbers of variables, it may be more efficient for you to put multiple variables on one row, and that's possible to do. Now I want to talk about getting export files converted into actual SAS files. So the export files, when you're reading them into a SAS dataset, you're going to need to use the export engine within a libname statement, which we'll see shortly. And the export engine simply creates files in a transport format. And effectively what this means is that there are many different operating systems that people can use now. Some people use Mac operating systems, some are using Windows XP, and others are using Windows 7, and now Windows 8, and so on and so forth. And what the export files allow you to do is to package SAS data sets into this export file, send it to somebody else, and then that colleague of yours could unpack the export file and convert it back into a SAS data set in a way in which the new SAS data set is optimized for the operating environment that you're using. So if you're using Windows XP, you could create a SAS file or take an existing SAS file, turn it into an export file, send it to a colleague who's using Windows 7, and they could unpack that file in Windows 7's in a way that it would run and perform optimally given that environment. And because there are so many different operating systems available today, there are many more XPT files out there. CDC more frequently now is putting data online in an XPT format. So I like to go over this example quickly. And it's not terribly important that you understand the dynamics of how a SAS file in Windows XP is different than Windows 7, for example. What I want you to get here is the basic syntax so that you can quickly take an XPT file and save it as a permanent SAS data set on your computer. And it's pretty straightforward to do that. And I would say the easiest way to do it is to just use a data step. You could also use proc copy, but I'm going to show an example with a data step. So the first thing you'll need to do is make sure that you have specified a data library a permanent SAS data library where you want to save this new SAS data set. Usually if you've already run a libname statement previously in your code, you may already have that existing. And if not, you should just specify the libname statement at the time that you want to save the SAS data set from the export file. So in this example, I'm creating a SAS data library named Epic, using a libname statement, no different than what we've done previously. The thing that's new is this second libname statement, where I'm creating a SAS data library that will point to the actual export file. So here I'm naming my SAS data library, or I'm providing a libref called XPT. This is user defined. I could have named it anything I wanted. I chose XPT for lack of creativity. And SAS will know that when the XPT libref is specified, it should go to this file location and this specific export file. So that's a difference from the libname statements we've seen previously where we only point to file folders. Now we're pointing to a specific file in a specific location. And the other new piece of information is you have to specify the export option. So the XPORT option is an actual SAS option, and you need to type it in just like this. It tells SAS that this data library should invoke the export engine. After you've specified the location where you want to save the new SAS data set, the specific file of the export file, where you want to extract the SAS data set, then you can simply run a data step. So this would look like any other data step. We're telling SAS with the data statement, create a new SAS data set called epic.demo_c, and then we use a set statement telling SAS, start with the data set located in the libref XPT, and the name of that data set is demo_c. Okay. So generally speaking, if the XPT file has the name demo_c, the SAS file packed into it will be demo_c as well. So this usually, the beginning of the file name usually tells you what the actual SAS name embedded in the export file would be. And this would allow you to extract the SAS file from the export file and save it as a permanent SAS file on your computer. Here's an example in the code. Again, the libname epic. Then you would highlight and submit your export libname statement. And again, this is the place where you're actually going to tell SAS the actual name of the export file. So you don't just go to a folder location, but you have to specify all the way down to the specific XPT file. And then you simply run a data step. So with this data step, after running these previous two libname statements, SAS is going to look in the XPT data library. It's going to find a SAS data set called demo_c that is packed into this demo_c.xpt file. And it's going to then write out a new SAS data set called demo_c to the Epic data library. And you would submit that, and it would run. And that's it. And then you get some additional information about the SAS dataset that was created in your log file. And if you just wanted to create a temporary SAS dataset, you could have done that also. The only difference is that in your data statement, you would use the work libref, and all the rest stays the same. Here's some additional information provided about that. And then just a quick summary. So as a reminder, for the most part in this class, we have talked about merge statements and set statements within the context of a data statement. Today we learned how to use an in-file statement to read in non-SAS data. And we also talked about how to read in XPT files and also Excel files, data files, SPSS files using menu-driven import wizard. And then finally, I just wanted to mention SAS system options. The system options are just instructions that affect your SAS session. So how long are the lines that print to your output window? How many pages are there? Do you want dates printed, etc. Oftentimes, it might be the first statement that you submit to SAS to set up the operating environment for that particular session, although you can specify them at any time throughout your SAS session and anywhere in the editor file that you would like. Notice that when I show an example of this, you'll see that these are not procedures or data steps. It's one of the rare situations in SAS where you'll have just a standalone statement that is not within the body of a proc or a data step. And the basic syntax is that you use the word options, and then after that you specify whatever options you would like, ending with a semicolon. We'll jump back into SAS and take a look at that. In this example, I'm invoking the options statement, telling SAS I'm about to specify some options for this SAS session. And I'm specifying three options. First, I'm telling SAS that I want the line size to be 80 columns wide, so line size controls how wide each row could be in your output window. Then I'm saying I want the page size to be 80. That means that any page in SAS will only have 80 rows to it. before SAS gives a hard page break. And then the no date option. The no date option simply suppresses the date from automatically printing to the output window. So you could just highlight that and submit it. And as long as there are no errors, then SAS won't give you any more information. You don't need a run statement when you submit an option statement. So now SAS has taken these options and it will, moving forward, use these specifications for the rest of this SAS session if you were to be continuing. All right, so again, in summary, we use the SAS menu-driven import wizard to import an Excel file, and that import wizard could be used to import many different file types. We use data steps to read in non-SAS data, particularly using data that are stored in text files. We talked about INFORMATS in the context of reading in raw data from text files. We saw a demonstration of how to convert an XPT file to a SAS dataset, and you learned how to create some SAS or modify some SAS system options.